let's talk about creating models from applications with functional data. Let's begin with an example. Jack plants a 5-centimeter beanstalk in his backyard. Jack notices that each day the beanstalk is 15% taller than it was the previous day. Find a function for the height of the beanstalk as a function of the number of days since it was planted. Notice this problem has two pieces of information. We're told an initial height of the beanstalk, of 5 centimeters, and we're told a growth rate. Each day it's getting 15% taller. And we'd like to come up with a formula that will give us the height of the beanstalk on some arbitrary day in the future since it was planted. Let's begin by discussing the general approach for these types of problems. The first step is to identify the relevant function type. The options might include linear functions, quadratic functions, exponential, etc. For this, you'll want to look at the problem, see what type of growth or decay is being described, and then pick the relevant function which would match that. Next, we would want to choose the dependent and the independent variable. Here we identify what variable depends on which other one. This is the hardest step. We want to next create an equation modeling the relationship between the variables. Using the information in the problem, see how those variables relate to each other. The problem likely describes several pieces of information, and we want to make sure that our model is valid for at least those pieces. Let's go back to our beanstalk problem. So, to begin this problem, let's start with the first step, identify the relevant function type. Here I'm told that the beanstalk is growing 5% taller each day. That means that the function type I want to deal with here would be an exponential function. Why do I know it's exponential? Well, I'm not told it's a fixed amount taller each day, but rather a percentage taller than it was the previous day. So if I was told that the beanstalk grew 2 centimeters a day, that would be a linear function type. Whereas here, each day it's growing even more because it's 15% of the previous day's height. So therefore, the growth is exponential. Next, we want to choose the dependent and the independent variable. Here we're asked to find a formula for the height of the beanstalk as a function of the number of days since it was planted. A natural choice might be something like h of d, where h is the height of the beanstalk, and d is the days since it was planted. Alright, the next step is the crucial one. We want to create an equation modeling the relationship between the variables. So I want to come up with a formula for h of d. Well, when d is 0, that's the day it was planted. It was 5 centimeters tall, so I know somehow I need a 5 in this model. Well, how tall is the beanstalk going to be the next day? It's going to be more than 5 centimeters tall. It's going to be 5 centimeters plus 15% of 5 centimeters. So I can think of that as 1 plus 0.15 would give me the height the next day. Similarly, for future days, I would keep modeling the previous day's height, multiplying by a factor of 1.15. So I can then write an exponent of d here, which will take care of that daily increase for me. A simplified way of writing this might be 5 times 1.15 to the d power. You might be tempted here to move the 5 inside the parentheses and change this to 5 times 1.15 all to the d power. But notice the d power only goes with the 15% increase each day. It does not go to the 5 term. Otherwise, our beanstalk would be getting bigger at a much faster rate. Alright, now we want to check our model with the given data. We're told that the plant was 5 centimeters tall when it was first planted. That means that we have the data point of h of 0 should be equal to 5, because when time was 0, the day since it was planted was 0, our height was 5. If you plug that into our model, h of 0 would be 5 times 1.15 to the 0th power, and hopefully remember any number raised to the 0th power is 1, so this would be 5 times 1, or just 5. Excellent, so for the given data point, it matches. Also, you could also check a further point. So for example, I know that after 1 day, my plant should be the 5 centimeters it already was tall, plus 15% more. And you can verify that that's indeed what the model would give you. So we'll check that one as well. Alright, let's try one more example. Consider the following. A school sports team is having a bake sale. They spend $50 on ingredients for baking cupcakes. They sell cupcakes for $2 each. Express the net income from the bake sale as a function of the number of cupcakes sold. Let's start with our steps again. Identify the relevant function type. In this case, I think this problem is linear. Each additional cupcake sold gets me a fixed amount, $2. Unlike the last problem where I got a fixed percentage, that was giving me a higher total amount each time, whereas this time each additional cupcake only gets me $2 more. So it's a linear function. Now I want to choose the dependent and independent variables. Since I'm talking about net income, I'm going to use the letter I to represent net income, and I want it as a function of the number of cupcakes sold. So I'll use C for cupcakes. So as a reminder to myself, my dependent variable is income, and it depends on C, the number of cupcakes sold. Alright, now for the trickier step, we want to create an equation modeling the relationship between those two variables, income and cupcakes sold. Let's begin by doing that. So I know that each cupcake sold will bring in $2. So if I was just selling cupcakes, if I sold 50 cupcakes, I would expect to get $100, or 50 times 2. If I made 1,000 cupcakes and sold them, I would expect to get 1,000 times 2, or $2,000. So the way I would model that would be $2 times the number of cupcakes sold. However, look back in the problem, notice we spent $50 on supplies at the beginning. So this is money that's not part of our income. It's money that we've spent and lost. So we would expect this to be present with a negative term, minus 50. So if I sell 50 cupcakes, I'll make $100, but I will have spent $50 on the supplies for a net income of $50. That's where we're going to try to check our model with our given data points. So for example, suppose I sell no cupcakes. If I sell no cupcakes, I don't bring in any money, and I've just lost the money I've invested, namely the $50 I spent on supplies. So I0 is negative 50. That makes sense to me, so I'll say check. Yeah, that works. As another example, suppose I sold 50 cupcakes. Well, if I sold 50 cupcakes, I would make 2 times $50 in income, but the net income, I'd have to subtract off the $50 I spent on supplies, or 100 minus 50 is 50. And since we're talking about income here, that has units of dollars, much like this one does. So those seem to work. Now you know the general steps for modeling using a given application problem. Thank you, and happy learning.